intro, and thank you all. I'm thrilled to be here. Let's start with a show of hands. Raise your hand if your team is responsible for shipping production code today. Okay, good. Most of us here. Keep your hands up if you can live with the code that your teams are shipping today. Okay. Oh, good. Keep your hands up if you feel great about the code that your teams are shipping. Okay. Quite a few have gone down. Okay. So let me just one more question. Keep your hands up if you think that your team's code cannot possibly get any better. Okay, there we go. So can we set a higher bar for the code we ship today? So based on the number of hands that went down, I think there's a bit of room to do so, right? And that's what we're going to be exploring today. Why setting a higher bar matters, how code habitability can help set that bar, and how AI coding assistants get us there. First, a bit about me. I've been doing this for about 20 years. I help orgs of various sizes as an engineering lead. Working at ThoughtWorks over the past 5 years has exposed me to a broad variety of code bases and challenges in complex business domains, such as automotive, health and wellness, and financial services, just to name a few. But this is really what gets me up in the morning. Coaching software engineers to deliver their best work. That means shipping code that we're professionally vested in, and pushing beyond what's just merely acceptable to what's possible. And in the past couple of years, I've been working with teams on how AI coding assistants can improve the way we work and the code we ship. But does that even matter? So to help answer this, we need to set some context first. Let's have a look at what developers think about generative AI, or as we say, GenAI tools. So it turns out software developers are starting to love GenAI tools, such as AI coding assistants. The most recent Stack Overflow developer survey found that 74% of developers say that they can focus on more satisfying work, and 72% of all respondents are favorable or very favorable of AI tools. Further, we recently collected NPS for GitHub Copilot internally, which scored the AI coding assistant in the favorable range. So apparently there's a good reason to like these tools. With GenAI, it's never been easier to write code. Research by GitHub Next found that 88% of developers say they're more productive, and in a controlled experiment, tasks are completed 55% faster with AI coding assistants. Finally, Stack Overflow dev survey showed that 81% agree increased productivity is the biggest benefit of AI coding assistants. So as coding gets easier, production code grows at a faster rate. So it's no surprise that we're seeing an unprecedented volume of code in production. Here are some stats from GitHub Octoverse 2023. 4.5 billion total contributions, 98 million new projects, and 81% of this activity, important to note, that happens in private repos, which they themselves are growing at 40% year over year. Okay, now for the bad news. 80% of developers are not happy at their job. Roughly 2/3 of developers say it's because of tech debt, while a third report issues with build stack complexity, deployment stack complexity, reliability of tools and systems. This corroborates what we're seeing in code bases across multiple industries. Refactoring is becoming a dying art, leading to incomplete rewrites scattered across code bases. Our efforts to pay off the debt backfire, and we end up adding code complexity and proliferating the tech debt. So I think we have a problem. What are we going to do about it? So I'm not saying it's entirely up to us, but maybe there's an opportunity to lead by example here. Okay, so let's talk about that next. How do we set the bar? So inspired by the late great architect Christopher Alexander, Peter Gabriel coined the term habitability in his book, Patterns of Software, way back in 1996. Since then, several have used this as a framing for describing better code. Sarah May has spoken and written at length on this topic since 2017. We have Kent Beck using habitability in his test desiderata model for describing better test code. And most recently, habitability served as inspiration for Dan North's qubit properties for designing good software. So many others have written and spoken on this topic, too many to mention right now. For today, I'm going to stick to the fundamentals and refer back to Peter Gabriel's original definition. So what is habitability? It's the characteristic of source code that enables programmers, coders, bug fixers, and people coming to the code later in its life to understand its construction and intentions and to change it comfortably and confidently. What does it do? It makes a code base livable like a home. And this is what we want in software, that developers feel at home. They can place their hands on any item without having to think too deeply about where it is. So, I mean, that sounds all well and good, but how do we really get there, right? So let's look first at the effects of low habitability. What does it mean? First of all, brittle code. Any change yields a high likelihood of something breaking. Uncooperative code. When it does break, it takes longer than it should to fix. Rigid code. Adding features take longer than they should. And then finally, unpredictable code. Any change takes orders of magnitude longer than expected. Longer than it should. Okay, so what that means is that we have this intrinsic belief often that if the code was better designed, more habitable, then it would take much shorter. We find ourselves saying, it shouldn't be this difficult. It didn't used to be this difficult. So let's just get concrete on how poorly habitable code looks like. So tests are non-existent, confusing, flaky, or slow. If we can't have confidence that our code is working, or that our code keeps working as we change it, then we can't make progress. We have to trust our tests. On the other hand, implementation code has elements with ambiguous or misleading names, elements being really anything: variables, methods, properties, classes, functions, modules, you name it. Implementation code is organized or structured in a confusing manner. It's needlessly complex, or it has entangled dependencies, bidirectional, circular, unnecessary, and so forth. Now let's work up to what high habitability looks like. Tests pass or fail when they're meant to. They express what is being tested and why that's being tested. They communicate the code's design. And finally, they exhibit established design principles. And now finally, the implementation code, intention revealing naming and structure. It's as simple as we possibly can make it, has manageable dependencies, and finally also exhibits established design principles, which I'm not getting into today because it is a big topic. We're just going to really scratch the surface here, but I think this is enough to get us started. So before we jump into the third section of the talk, I just want you all to take two big takeaways from this part about habitability. Number one, habitability of test code is as important as that of implementation code, if not more important. And second one, it's not just about the code we understand, or it's not just about understanding the code, it's also about code that we can change comfortably and confidently. Okay, next, I want to walk through a demo of how AI coding assistants improve habitability. I'll be using GitHub Copilot for the demo, but I'll touch on takeaways that apply to all coding assistants at the end. I'll also be doing this in Ruby, but the takeaways will apply to any modern high-level programming language. So let's jump in. Okay, we've inherited a URL shortener. Two public methods exist on this class. One, to shorten the full-length URL and store the original in the database, and the other, to retrieve the original full-length URL and raise an error if we can't find it. We need to extend our URL shortener so that we can use a better URL shortening algorithm, and also so we can use a more scalable database technology. To achieve our goals, first we verify that the URL shortener is safe to change, and second, we redesign URL shortener so that it can be extended. So let's have a look at the code that we're starting with. So for this demo, don't worry about reading and understanding every line of code up on screen. I'll share a link to the repo at the end if you really want to dive in. But for now, I'll guide you through the highlights. Let's start with the tests. So I'm seeing a number of issues off the bat, but I'm going to ask GitHub Copilot first. How can I improve tests in selection? We'll dive into these suggestions in a moment, but for now, let's summarize. Two out of these three recommendations I would say are solid. The second one I'd be wary of. It suggests adding edge cases for handling invalid input. So every unit of code doesn't always need to handle every possible edge case. In the real world, we think through how this unit of code fits into a larger system before dismissing this suggestion, right? There might be a validator in front of this. But for our interests, we're going to skip it for now. Next, we ask the coding assistant, how can I move in small steps? This is a foundational refactoring practice that's especially important when working with AI coding assistants. Let's review each of the steps it suggests. These two suggestions help improve test isolation. This one here, it's replacing a shared variable with a memoized helper, and this helps improve maintainability and speed of our tests. And then, as discussed, we're going to skip the testing of the new edge cases for now. Finally, Copilot does remind us to run tests after every step, which builds confidence in our code changes. Okay, so we're going to apply the first step here. We're changing before all to before each. That makes a fresh database connection so that we don't have state carrying across every test example. So we make that change. We run the tests. Tests pass. Next, we make the change to pass in the database as an argument into our method, and we change the implementation. We rerun the tests. We hit an unexpected test failure. So it's not obvious what the error is. It's a little cryptic, this error message, so I'm going to ask GitHub Copilot for help. Here's our prompt this time. Workspace fix code in selection based on error message in terminal selection. So this prompt leverages actions and variables in GitHub Copilot. These UX affordances allow us to add context to the underlying prompt that's constructed by Copilot and passed to its NLM. So when we review Copilot's response, we recognize that it diagnosed the issue correctly. It also provides us with updated code. So let's drop that in and rerun the tests. Back to green. So far, so good. Let's keep going. Now, let's ask Copilot to help us clean up what we've got so far. Propose a cleanup to code and selection. How did it do this time? Again, it makes 3 distinct changes to the code all in one go. Let's just walk through them first. Removing excessive database close calls and removing an unnecessary local variable. These lead to a simpler design. And then this third one, so I've chosen to skip this suggestion because I'm not yet sure where the logic for generating short URLs is going to end up. It might be in a new class entirely. This recommendation is really extracting to a private method for readability. It's not for reusability. It's just called once. Essentially, I don't want to waste time extracting into private methods if I'm going to have to inline it later. This is yet another example of where me as the human coder, right, will always have more context than a coding assistant. Another key thing that Copilot failed to do is it failed to break down the work into smaller steps. So let's do that right now. So we're prompting Copilot again. I want to make incremental changes. Just do the change with the removal of database close calls for now. So here we go. So it successfully satisfies our request, generating code update that just removes the DB close calls. Let's drop that in, change now, and rerun the tests. We're green. So recalling our original goal of improving the extensibility of our code, we're going to ask Copilot to consider solid principles and suggest a refactor. So what it suggests here is for the database connection to be handled by a wrapper class. So while this approach could work, the key issue here is that dropping this in as is would cause our tests to fail. This makes it an invalid or unsafe refactor move. Let's see how it does if we point this out. We're initializing the database connection outside of the class. Can you propose a refactor that won't break the tests? With the new recommendation, it's the URL-generated logic that's extracted. It's a non-breaking change, but it's still not extensible. So let's further prompt GitHub Copilot on what we actually need here. We want to easily swap out the URL-generating logic. Can you suggest a refactor that would enable this? So the code it suggests does the job using dependency injection. The URL generator is now passed into the main URL shortener class. So it is still a non-breaking change, and we now have the extensibility we're looking for. So great, right? But that's not all we get from Copilot here. It gives us an example of a static URL generator that always returns the same URL. Hold on a second, though. Do we want that? So unwittingly, it pointed us to something we absolutely want to avoid. We uncovered an edge case that we definitely care about because it originates within our unit of code. So before we adjust that, though, let's make sure we finish up our refactor here. We're going to drop this in, make URL shortener extensible, and rerun our tests. We're good. OK, so now let's get Copilot's help once again, this time with handling our edge case. First, we clearly explain what we're trying to avoid. We don't want a static URL generator because all the short URLs would collide with each other and full URLs would be lost or overridden in the database. We don't handle the edge case that a generated short URL already exists in the database. So can we add a test for that? So again, this is all one prompt that I'm passing into GitHub Copilot chat. So it provides us with a test, as well as a detailed description of what the code is doing. So while I'm a believer in self-documented code, I do appreciate this, as the syntax for mocks, stubs, and test doubles varies widely across languages and testing libraries. So the explanation makes sense, and the test code looks good, so let's drop it in. We run the tests, we expect a failure, and we get one. Let's get Copilot to take the next step and get us from red to green. We now have a failing test in terminal selection. Can you now suggest an update to the implementation in selection? The AI-generated code looks good, so we're going to drop it in. And we're going to rerun the test, and we're green once again. OK, so we made it. Let's give ourselves a round of applause. We made it to the end of the demo. OK, whew, coding demo on the afternoon of the second day of the conference. OK. OK, we've done enough to learn a few things, so let's review. So did GitHub Copilot help us improve code habitability? So we improved test speed and maintainability, memoized helper functions using let, that's a Ruby thing, use of test doubles and stubs for test isolation. Secondly, improved code design. So we have a simplified behavior now, removed unnecessary database calls. We added extensibility. Now we dependency injected logic for generating URLs. All great. Miscellaneous improvements helped identify an important edge case, right? I wasn't thinking of that. Helped point it out. Expressive naming, readable code was what was generated, so well done there. On the negative side, not all suggestions provided were relevant to us, right? So we, as the human coders, will always have more context than the AI coding assistant. Even if the AI coding assistant would be able to see the whole code base, you're still working on a code base with some outside of context outside of the code base. Otherwise, you wouldn't be working on the code base, right? So second, needed repeated requests to make small incremental changes. So there are prompt customization techniques that help potentially avoid this. It depends on the tool. So there is potentially ways around this. And then finally, suggestions lack novelty. So I don't know if anyone picked up on this, but what about using a constructor? So we're using an object-oriented language, right? We have a class. We're passing in dependencies. Why was that not suggested to be done in the constructor? Might be better. In any case, let's go through some general guidelines now that apply to all coding assistants. What to avoid, what to do instead. So context poisoning happens when the AI coding assistant provides recommendations based on code we want to move away from. The response to this is using context selectors to customize the underlying prompt passed into the LLM for really zoning in on the context you really wanted to use. So has anyone come across a PR that's too large to review properly? Yeah, of course. I mean, who hasn't, right? So this is essentially happening all the time, continually when you're using an AI coding assistant. It's just an onslaught of code, right? Consequently, we fall into this cognitive trap of review fatigue very quickly. So to offset this, we prompt the coding assistant to break down the steps into incremental changes or baby steps. But even when we're carefully reviewing every line of code, we still fall into this trap of zoning out of the big picture. By design, right, AI coding assistants respond with what you're most likely to expect. So to counteract this, we pass back into the coding assistant the code it just generated, and we try to get it to interrogate the code or the code or advice it just generated. So we're passing it back in. So lastly, it's easy to get sidetracked with Copilot. That's why we include a human pairing partner whenever possible. Again, it goes back to the larger context. Do we have time for rabbit holes, or are we working on a tight timeline? So I get it, all right? It's a challenging time to be a software engineering leader today. But I also think it's kind of an exciting time, right? Kind of reminds me of when I got my first power drill, doing odd jobs around the house, went from tiring chores to fun projects. But just like with any power tool, these AI coding assistants can feel clunky and awkward at first. But when they do work, oh boy, do they ever work. Just remember, with great power tools come great responsibility. So let's go out and use these tools responsibly. And a big part of that is to raise the bar from shipping code that we can live with to shipping code that is a joy to live in. Thank you.